We will continue our model building using HLM to continue to analyze the basketball data. And this step, what we're going to do is look at the means as outcome model. And so in this case, we'll be looking at the influence of mean coaching experience on life satisfaction. So this is a level 2 variable because it's the average for each team of coaching experience. And notice that shots on 5 is removed from the level 1 model. So let's look at how we would do this in HLM. So we can go to File, and we can make a new MDM file. But if we've created a prior MDM template, which you automatically do when you do the original analysis, you can go back and access that template and open it. And so what that allows us to do is just choose our variables again. So we can, the variables, the team ID, and then shots on 5 and life satisfaction, you can see are already at level 1. And then our level 2 variables are already chosen, so we don't need to go through that step again. So we can go ahead and we can make the MDM file, which we have to do, and then we get our descriptive statistics, of course, and then we can close that and then go done. So now we can build our model, and we're going to enter life satisfaction as our outcome variable. This is the intercept, this is the random error term, and then we're going to at the level 2 model, we're going to add coaching experience, and we want that grand mean centered. And when it's in bold, you know that it's grand mean centered. And so then we'll go ahead and run our analysis. So this is our output, and again I have an annotated output that I'm going to show you. And so research questions that we could ask around the means as outcome model. Is mean coaching experience significantly related to life satisfaction? Or alternatively, do teams with high mean coaching experience also have high mean life satisfaction scores? Again, make sure that the coaching experience variable is grand mean centered. You'll notice this is the mixed model, so we have gamma sub 0, 0 plus the slope gamma 0, 1 for coaching experience plus the random error term for the level 2 model coaching experience, and then our level 1 random error. So it's just the two equations combined. I'm going to skip down to the first important piece of information that we get from the output. So we can see that our at the individual level, at level 1, our variance around the grand mean is 14.61. This is very similar to the unconditional model because if you notice, for the unconditional model, there were no independent variables in the analysis at level 1, so shots on 5 was not included. Tau for our level 2, or our group variability, is 1.67, so that's quite a bit less than we saw with the unconditional model. So we can look at the proportion of team or group variability in life satisfaction that's explained by adding coaching experience. And so we can take the tau from the unconditional model, which was 14.96, and tau from this model, the means is outcome model, which is 1.68, and then divide by that variability from the unconditional model. And so we can see that 88, almost 89% of the variability across schools is explained by mean coaching experience. The reliability, again, in this case, is the overall reliability of the ordinary least squares regression estimates for each of the team intercepts. So if we compute the reliability of the estimated mean life satisfaction score for each team and average it across all teams, we obtain the reliability estimate. In other words, it's the ratio of the estimated life satisfaction means across schools divided by the estimated life satisfaction means plus sampling error. So that's sigma squared in this case, which we can get from the beginning of this output. So we move down here to look at the interpretation for the fixed effects. Remember, we want to use the report, or the part of the report of the output that calculates robust standard errors. So we can see in this analysis that the fixed effect for the intercept level 1, equation B0, which is the grand mean for life satisfaction across teams, is 14.81. So for this analysis, then at level 2, we added coaching experience, mean coaching experience for each team. So these results show that the grand mean centered coaching experience is significant. And so what that means is that when we look at the coefficient, we can say that the grand mean for life experience increases or decreases 4.78 units with 1 unit, or year in this case, increase or decrease in coaching experience. So let's move down to the random effects. We can see that the intercept is still significant. So we see that's still highly significant. So what this means is that even though we added coaching experience to the model, there's still a significant amount of variation in life satisfaction yet to be explained. So we can move to a more complex model that includes other independent variables to try to explain that source of variability around the grand mean. So let's move down to model fit. So the deviance value for the previous random coefficients or intercepts model, if you go back and review that output, was 1,436.53. So if we take 1,676.98, which is the deviance value for this model, the means as outcome model, we obtain a difference of 240.45. So according to Hawks, what we can do is we can take the difference in the deviances to evaluate the significance of the increase or decrease in model fit based on a chi-square distribution. So the number of estimated parameters for the random coefficients model was 4. And for this model, the means as outcome model, it's 2. So 4 minus 2 is 2. So we can go to our chi-square table and we can determine our critical value at the 0.05 level of significance. And so in this case, our critical value is 5.99. So the difference of 240.45 clearly exceeds that critical value. and it indicates that the random coefficient model really fits the data significantly better than the means as outcome model.